Okay, so I type in this equation on page 26. I hit graph. Mine does not look very good. So I'm going to try zoom 6 first, do a standard. Still not very good, but I do expect it to be pointing down because A is negative, leading coefficient is negative. And I see one of the legs here, so I'm just going to chase it. I'm going to try zoom fit, see what it does for me. Zoom fit is trying really hard. Zoom fit, any of the zooms don't know we're doing a word problem. It just doesn't know. So all of this here, all of this I do not really care for. So I'm going to bring my x min really close to the y-axis. So let's change the x min to like -2 or something smaller than what it is right now, and then hit graph again. And so now I'm kind of focusing a bit more on what I actually care about. I also don't care about all this area down here. So my y min, I'm going to bring that up closer as well. Okay, so I'm going to go to window and change the y min to -2 as well. Something that gets me way closer, and that is much better, right? I don't want to see the negative quadrants, so this is better. I still need to chase it to the right, and I need to go up a little bit, so I'm just going to do that. Y max is 150, let's say, and my x max, what do you think, double it? Double what it is right now. Let's try 20. So this is what I have on my window, and that's much better. So that's kind of what I'm hoping that part, we've got that figured out, okay? And if you need more help, come and see me after this. Come and see me anytime at lunch. It might only take 10 minutes to sit down and figure it out, okay? All right, so this is the graph. It says create a labeled graph including marking the endpoints of the function. There's one thing that my key did not account for, is the graph stops when the flare burns out after 12 seconds. So this graph on the answer key shows that it's hitting the ground. So technically this would not be a correct graph. It would stop technically right here where 12 is. It should stop right there. So I'm going to erase this and make some changes. There was my x-intercept there. I'm just going to get rid of that as well. And let's find the point 12, right? Let's find when x is equal to 12. Second trace 1, x is equal to 12. It's at 47.52. I will make note of that somewhere. Okay, I'll make note of this point somewhere because I'm going to need that. So 12, at 12 we are at 47.52. Stops here, right? Stops there. So you want to make sure you make a note of that. So 12, where's 47.52? This is 50. So 47.52 should be somewhere in there. So I'm just going to make it work, right? Look at that. And you thought art would never make it into math, right? Sometimes you just have to make it look like it works. Just like carpenters. You think it's perfect, but it's not. They just make it look perfect. Okay. And so that is the first thing I wanted to address, the fact that it stops here. My graph was wrong for that purpose. I did find the vertex, I did find the y-intercept, so those are important points to always have. The intercepts, if possible, and the vertex. Remember, you label your axes with units. That's important if you want full marks. And then the other one I wanted to address, which I don't know what happened, to be honest. Sometimes I write the questions and I make my key and then I change it and then I forget to adjust my answer key. So C, for how long is the flare above a height of 90? That should have been a pretty straightforward question. I don't know, I think I made it too complicated. But this is a scenario. It stops at 12. It stops here technically. It no longer stops on the ground, right? So the graph technically should only stop there up to here. But that didn't even matter for this question. You just had to make sure you draw your 90 line. And then you find first time and second time it hits the 90. And we simply subtract these two values. That's all that you had to do there. And the answer is 8.80 seconds. So maybe disregard whatever happened here. I don't know. Maybe it was like midnight and I really need to go to sleep. It's a different way. This one talks about time below. This one is time above, and that's what we care about. So this is the final answer for time above. This one right here does that. It should be 1016 minus 1.3607. That's what it is, no matter what happened on the answer key, okay? So I hope that didn't throw you off too much, but it's 880 is the time, okay? Let's talk about 27. 27, is that, do you have 27 written down? Because I did post a video on cubic, but this is not the one, perhaps. Let me see, the cubic function. Yeah, this was the video, right, that I posted? If you watched it, this is the one I solved on the video, because I wasn't here on Friday. So this is a roller coaster scenario. It's a cubic function. Remember, before you graph, tell yourself the leading coefficient is negative. So, sure, the cubic has variations. It has the 2 turns. It has essentially no turn. It doesn't matter. It's gonna go from quadrant 2 to quadrant 4. Sorry, quadrant 4, yes. 2 to 4, I have to envision this. No matter what, it's going to do that. Another thing, I know it's Monday and you're looking forward to tomorrow being off. But sometimes, if you zoom into the cubic and only focus on the part we really care about, it looks like a quadratic. What are you talking about, Mr. Erickson? What is that? This is important because some students are like, wait a minute, like this is not a cubic, right? Because you zoom in. So let's say you're trying to graph this and this thing does this, right? And you know it's a word problem. You know you can't have negative time. All of this is not relevant to us, right? And then so there you're like, wait a minute, that looks like a quadratic. Am I doing something wrong? You're not doing anything wrong. It's just that in this particular case, we're focusing on quadrant 1 and we disregard, but in general, you still have that shape of a cubic, right? So don't let that throw you off, please. It's just another question. It's just, you have to kind of restrict the graph to the parts that are useful to you, okay? I think that's all I wanted to say. Maybe I should mention, like if you look at the graph, once you graph this, in this case, we start at time 0, right? This roller coaster goes underground. So if you wanted to figure out how long or what's the horizontal distance, in this case it's time. X-axis is time, so how long did this roller coaster stay underground? Obviously you subtract these two. And so in this case, guys, if it asked you how long was it above ground, if it asked you that, it would probably be easier to figure out how long did it stay underground and subtract that time from the total travel time, which happens here at that x-intercept. So that's this x-intercept here tells you the total traveling time. If you were to subtract this little dip here, that time you spent there, then you find out all the time above ground, okay, what remains. I think that's it for that. Let's go back to a linear. I don't think I did a linear with you guys, but I'm just going to go straight to the answer key on page 28. Go to 28, and I'm just going to clarify that. If you haven't tried a linear, remember, it's just a straight line, and sometimes it looks a little weird, but remember, whatever's in front of the variable is the leading coefficient. That tells me the end behavior, how it's going to behave. And it tells me that hours are my x variable, and voltage, whatever's on that side, is the y variable. So that's every single point. A is negative, leading coefficient, so I'm expecting this. I do know my y-intercept. It's that constant there. Okay? So when I graphed it, why did I stop there? I stopped there because the question says, graph on your graphing calculator, the voltage for 60 hours of use. That's not true. This one doesn't show 60, does it? I think it is because of this. C said if the battery must be replaced when the voltage reaches 11.8 volts, then how long will the battery last before it must be replaced? So I figured out at 11.8 volts, I figured out how long that would take. So I basically graphed the 11.8 line right here and figured out that time. And I think it's over here, right here. 17.74 hours. And it stops at 2 hours, so terrible graph. This is a terrible graph. I don't know what happened here. I have to redo this key, and I'll post the updated key maybe tomorrow when I'm off. I'll redo it because it's just not good. Okay, but if you at least were able to find the points and follow along and get this on your screen, that is what I wanted you to try first and foremost. Okay, so this one goes down this line on page 28 at the bottom. That is an example where the line actually goes up. Okay, so there's different scenarios, and how did we know that? The leading coefficient in this case is positive, so we did expect a linear that is increasing from left to right. Okay. Sometimes the province will tell you only graph until, you know, in this case, what does X represent? The number of years. Okay. So only graph it for the first 50 years. So they'll tell you stop there. Sometimes it's within the problem that it's going to tell you, hey, once you reach this profit, once the cost reaches a certain amount, we can no longer do it. Like we need to stop. So they'll kind of give you a hint where to stop. Okay. All right. I will stop there. I'm curious to see